Hello everyone, welcome to my slide presentation. I'm Anichibike Silvanus from Nigeria, and I'm here to present my research paper that says preliminary in-silico evaluation of selected phytocompounds in Parkinson's disease management. And I implore us that during the course of this video, you can actually pause the video to get every bit of the information, because we will not be saying everything in the course of this video. Thank you. As we proceed, here are the outlines for this study. The introduction. As we all know, Parkinson's disease is actually a neurodegenerative disease that is marked with progressive neuronal loss and sometimes death of these affected patients. This has been a burden to the society, which prompted for our study. Statement of problem. As we all know, we have selected therapies and approved drugs in the market that we use to actually manage Parkinson's disease. But due to the long-term exposure of this medication, that's led to adverse effects and sometimes development of drug resistance, requiring higher dose of this drug to actually get the desired effect, which prompted us to actually explore the phytochemicals we have in plants as potential alternatives to offer promising avenue due to their diverse pharmacological properties and relatively fewer side effects. The aim of this study is to evaluate selected phytocompounds with multi-targeting abilities against selected proteins in the management of Parkinson's disease. Here are the objectives for this study, which are to identify the phytochemicals present in the potential plant of study, to study the drug likeness, to identify the proteins of target in Parkinson's disease, to perform molecular docking simulation, and also to carry out post-docking analysis to get our front-runner phytochemicals. As we said in the previous slide, due to the toxicity of this drug, which prompted us to actually explore natural products because they are rich reservoirs for biochemical compounds, and due to the nature of our study, we will not be using the traditional or conventional way of extracting phytochemicals because they are time consuming, which prompted us to use in-silico method because they are cost-effective, efficient means to predict potential molecular targets and interaction of bioactive compounds. Here are the methodology. You can pause the slide to go through them. During the course of this study, after data mining, we got that 75 compounds were selected based on the deposition in African Natural Product Database and other relevant published articles. During the course of this study, we focused on only 3 targets, but there are other targets you can actually see. But then these 3 targets we focused on are dopamine receptor, LRRK2 receptor, monoamine oxidase B enzyme. You can see here, this is the pictorial representation of the 3D format of the selected targets downloaded from the RCSB website. Ligands were selected and downloaded from PubChem. This is the docking validation. You can see the pictures of our ligand validation. We actually validated the ligand before we used it for molecular docking. We carried out drug likeness, filtration, in-silico toxicity assessment, and found out that 90 phytocompounds were found to be fit for this study using Datawarrior. We also sieved out phytocompounds with good binding energy. As you can see in the first result sheet here, that we did the molecular docking simulation 4 times. We got the binding energies and we calculated the mean and standard deviation, and phytochemicals that came above the red highlighted compound there is what we selected, and we found out that there are 6 of them that have multi-targeting abilities. We carried out drug likeness tests on them, that's the CNS drug-like property test, carrying out the TPSA value to find out if they are fit. We also carried out amino acid interaction, comparing the standard drug and the phytochemicals to see if they actually match each other in activity using Discovery Studio Visualizer. As you can see on our screen, the result sheet of everything we did, the comparison machine on your screen. This is an example of what the Discovery Studio Visualizer on amino acid interaction looks like, and these are just samples of the result. We also carried out Swiss target prediction, predicting the particular target class of these enzymes that these particular drugs act on in comparison to the phytochemicals we are trying to study. And we found out that the frontrunner compounds can actually be isolated from these listed plants we can see here on our screen. That's the Rosmarinus officinalis, cannabis plants, Withania semnifera. And in conclusion, 6 promising natural compounds we identified through molecular docking simulation to target potential proteins involved in Parkinson's disease, and we recommend that further studies should be carried out in vitro and in vivo to validate the test results. Thank you very much.